Okay, our lesson today is 6.1 through 6.3. We're going to look at solving inequalities. Go ahead and put today's date. And what we hope to be able to do by the end of the lesson is that I can solve and graph inequalities. Now, the big thing about inequalities is that equalities solve exactly like equations, except when you multiply or divide by a negative, the inequality symbol flips. So we solve inequalities exactly like equations, except when you multiply or divide by a negative, the inequality symbol flips. Now, just a real quick reminder what your inequality symbols are. Your very first one is x is greater than 2. So if you think back to grade school when you do inequalities, you have that little alligator and he's hungry and he wants to eat the bigger number. So if it's eating the x, that means x is bigger, therefore x is greater. Now the one below it says x is greater than or equal to 2. And the big one with that is to see the line underneath it means it's equal to it. Then over here we have x is less than 2. So if it points to the x, that means it's kind of calling x the little guy, telling him he's smaller. So if x is smaller, that means x is less than. And also, if you look, the symbol points to the left, so left is less. Same way down here, we got x is less than or equal to 2. So once again, that line under it means equal to, less than or equal to. Now before we can begin solving, we have to look at graphing inequalities on a number line. So when we graph inequalities on a number line, the first thing we have to ask ourselves is what type of circle do we need? So our circle. For when x is less than or greater than, so you notice it does not have a line under it. So when x is just less than or greater than, we use an open circle. An open circle is just circle not filled in. And that's because it does not include that number. It's not equal to it, so whenever we graph it, whenever we solve, we can't include that number that it's less than or greater than. Now, when it does have a line under it, for when x is less than or equal to or greater than or equal to, we use a closed circle. And we use the closed circle, when we use him, it means it does include that number, because if it's equal to it, we do include that number that it's less than or greater than, because it's also equal to it. So that's why it's a closed circle. Alright, then we need to figure out which direction we need to shade. So after we make our circle, we decide which way to shade. And it says for when x is less than, or when x is less than or equal to, it means less, so less than is to the left. So we're going to shade to the left. And for when x is greater or greater than or equal to, greater is to the right. So if you just think about your number line, all your negative numbers are to the left, so less is left. And then all your numbers keep getting bigger or greater to the right, so greater's to the right. Also, if you look, the inequalities point a certain direction. This inequality points to the left. This inequality points to the left, so we shade to the left. This inequality points to the right. This inequality points to the right, so we can shade to the right. So just as a little hint, when the variable's on the left side, like how it is here, when the variable's on the left side, we can shade the direction the symbol points. Okay, we can shade the direction that the symbol points. Alright, so let's look at some examples. Example 1. It says t minus 45 is less than or equal to 13. So we solved it the same way we would an equation. So we look at our t, we ask ourselves what's happening to the t. It's a minus 45. So the first thing I need to do is transpose my minus 45. Take him over here and make him a plus 45. So t is less than or equal to 58. And that's our answer. Now we're asked to check our solutions, and checks for inequalities are just a little bit different. So when we go to check it, you have to realize that not all of these will be equal to it. So rather than just using this number like how we would in an equation check, we're going to have to go back to our original inequality and say to ourselves, what is t if t is less than or equal to 58? Well, I'm going to pick 50 because 50 is less than or equal to 58. So let's replace t with 50. Okay, so 50 minus 45 is less than or equal to 13. Then 50 minus 45 is 5. And then we just ask ourselves, is 5 less than or equal to 13? Yes, it is. And once again, the reason why we checked this example with 50 is because we needed a number that was less than or equal to 58. So let's look at our second example. We're given 7 is less than x minus 4. Now, if you remember back in our notes about shading, we said we liked the variable on the left. So what I'm going to do is I'm going to flip it. That way, I can take this entire right side, write it on the left. Now, if you look at the inequality symbol, it's eating my x minus 4, and it's pointing to my 7. So it has to stay eating my x minus 4 and stay pointing to my 7. So everything flips, including your symbol. And now we just solve it. So we look at x. The only thing happening to x is a minus 4. So I transpose my minus 4, make him a plus 4. And he disappears. And it says x is greater than 7 plus 4 is 11. Now our instructions this time tell us to graph it on a number line. So we're just going to make a real quick number line here. We put 11 in the middle. A number less than 11 is 10. A number greater than 11 is 12. And we're going to say, right here, look to our inequality symbol. If x is just greater than, it's going to be an open circle because it's not equal to. And it says x is greater. Greater is to the right. And also, if you look, the symbol points to the right. So I shade to the right. That's all we have to do for that one. All right, example 3. It says to solve b over 7 is greater than or equal to 25. Except I'm going to change the direction instead of saying check, we're going to graph it. So if you look right here, we ask ourselves what's happening to b. It's being divided by 7. So the opposite thing to do is to multiply both sides by 7. 7's cancel, and b is greater than or equal to 7 times 25 is 175. So we're now going to graph him on a number line. Put 175 in the middle. Number less than 175 is 174. Number greater than 175 is 176. And we're going to go back to 175. We have to look right here to our inequality. It says b is greater than or equal to. So greater than or equal to means closed circle because it's equal to it. And once again, it points to the right. It says greater than's to the right, so I shade to the right. Okay, on to example 4. We have 8 minus 2x is greater than 14. So once again, we solve it like an equation. So we ask ourselves, if x is here, he's being multiplied by -2. He's being subtracted from 8. So the first thing I need to get rid of is my 8. So we're going to transpose our positive 8. make him a -8. He disappears. Now, we always have to use the sign in front. So if that's a -2x, I have to keep a -2x. Is greater than 14 minus 8 is 6. Now, last step to solve for x is divide both sides by -2. -2's cancel, and x is. Now right here, if you look, we divided by a negative on both sides. So when I divide by a negative, my inequality symbol is going to flip. So instead of it saying greater than, it's now going to say x is less than -3. And that's because when you divide or multiply by negative, you change directions. So x is less than -3 now. I'm going to graph this guy on the number line. And I'm going to put -3. Now when you deal with negatives, the farther left you go, the bigger the number gets as far as the absolute value of the number. So -4 is to the left because it's less than -3. And then to the right is -2. And then we say our inequality symbol says just less than. So less than is an open circle because it's not equal to it. And x is less is left, and also it points to the left. So we're good for example 4. Example 5 gives us 3x minus 4 is greater than 14. Same steps we look. Very first thing we need to do is transpose, so my -4 becomes a +4. And we're left with 3x is greater than 14 plus 4 is 18. Last step is to divide both sides by 3. Now we're dividing by a positive, so nothing happens. It still says x is greater than 6. And we graph this guy on the number line. So 6 goes in the middle. Number less than 6 is 5. Greater than 6 is 7. Go back, look at our inequality. Greater than, so it's not equal to, so it's open circle. Greater than means everything to the right, and it points to the right. Last example for us today. So this is example, I forgot my example number. This is example number 6. And we're 5p plus 7 is greater than 6p. So, first thing we recognize is that we're solving for p, but he's on both sides of my inequality. So I want my p on the left side. So I keep my 5p, he drops down, he's already on the left. But my positive 6p needs to come to the left and become a -6p. Now there's nothing left over here on the right, so we have to ask ourselves what wants to come to the right. Our positive 7 becomes a -7. And then we just simplify. So 5p minus 6p is -1p is greater than -7. Last step to solve for p is divide both sides by -1. -1's cancel. And p, and now you have to ask yourself, we divided by a negative, so what's going to happen to our inequality symbol? It's going to change direction. It's going to flip. And -7 divided by -1 is +7. And then it says to graph our solution, so we're just going to make a number line. 7 in the middle. 6 is less than 7. 8 is greater than 7. Then we're going to look. If it's less than, it's an open circle. We want everywhere to the left shaded. Points to the left and also says less than is left. So this concludes us for solving inequalities. Thank you very much.